Good afternoon, everyone, and welcome to our webinar. Today's subject is assessing flooding consequences of a new drainage design. And I'm Peter Coombs from XP Solutions, and I'm delighted to be working alongside Ludmila Fadeva, my colleague today. There's the agenda. What we plan to do is I'll give you an update on the latest requirements that are coming through, and maybe this will help to explain why increasingly we're hearing that people are being asked to produce virtually detailed design of roads and drainage systems right at the concept and the early applications of planning applications. So we'll put into context why that's maybe occurring. I'll share a model, a MicroDrainage model, and it's a model that's been created and analyzed so we can see what the extreme rainfall events are, the critical rainfall events on this particular development. And then I'm going to hand over to Ludmila because we need to put the context of the development into the context of the catchment more widely. And that's the work that Ludmila is going to do with XP Swim software. So she'll bring in the MicroDrainage model. She'll then introduce more information about the local catchment and then analyze the impact of the development upon the catchment and the catchment upon the development, all in the one model for you. We're also putting in some mitigation scenarios. So we can analyze these entities, but then we can also put in mitigation measures. So should we find that there are issues either affecting the development or coming from the development into the wider catchment, Ludmila's created some models there to share with us and show what we can do without breaking the bank, basically. So in terms of the guidance that's required, I'm not sure, it'll be very interesting to feedback actually at the end of the survey when we finish the webinar and you produce the survey to feedback and let us know whether you're being asked to implement this LASU guidance and whether you're aware of the LASU guidance. Basically, this a non-statutory technical standard is produced for sustainable drainage systems by the local authority, STUDS officers organization. So this provides more detail on how we can better comply with local requirements. So it will depend. You need to talk to your local authority. When you put in an application, you will apply to the local planning authority and they will refer you to the lead local flood authority. And you may well find that the lead local flood authority either have their own standard in place or maybe they're using the LASU guidance. And you can see here that there are quite a few different chapters within the LASU guidance. And we start off by looking at runoff destinations. So where should the development outfall to? The second chapter is looking at flood risk outside of the development. And historically, what we've been doing, we've been looking at peak flow rates, looking at discharge rates, limiting the discharge from the site, limiting the volume of runoff from the site. That's been worked on more recently, more closely, more recently. And we're now looking at the flood risk within the development in isolation, but now we're being asked to look at the flood risk outside of the development as well. This is one of the sort of bigger things that's coming through. So that's what we want to kind of focus on in the webinar today. With regard to the drainage, the key advice here is that you need to consider this at a really early stage. And when they say early, they mean it's an integral part of the land acquisition process. That's how early, where people need to carry out the due diligence process. So that's even before any planning applications are carried out. It's at the earliest stages when you're starting to plan out a development. And I think this is really sound advice. And I feel as though this is something that we've failed to do. Really sort of post-war, we failed to implement this, and now we're suffering from the consequences of not planning things out as well as we could have done in the past. So hopefully this will help to address that balance. In terms of the process itself, there's a nice little flow chart that's within this LASU guidance. We can see where you're working through a pre-application process, so you have a discussion there and lead on to either full application or outline. You may have Section 106 agreements implemented, so you're going to have conditions to your development and reserve matters. So it's all contained very early on, but you should have engaged early and you will therefore have no shocks and surprises, and the same for the client. We want to have all these issues out in the open very early on in the process. What we need to do is enter into discussions with not just the local planning authority, but the lead local flood authority. And this is really the nub. Every lead flood authority now has a flood risk manager. The ones that I've engaged with and spoken to, many of them would openly welcome early discussions with you. So I would encourage you to find out who the lead local flood authority flood risk manager is and make an approach, because you need to understand the issues that they're suffering from. They're very aware of localized flooding issues within their area of responsibility, and they would share that with you, because your development may well be in risk zone 1, up a hill, and you think, why on earth should we worry about drainage and flooding? We're up the hill, we've got dry feet, what's the problem? It's really what's happening downstream of the catchment, and they are fully aware of the issues that they're suffering from and what they're trying to help to alleviate and mitigate right now. So you should really gain that knowledge and understand the context of the potential impact of your development on something that's happening further downstream. These are sort of fundamental issues. So what we may be asked to do is look at things like strategic flood risk assessments, local flood risk management strategies, which the flood risk will have a copy of, maybe have to introduce surface water management plans, or there may be plans in place that they would share with you. Look at surface water flood risk maps, and that Ludmilla will show you in a second when we go live with the software. All of the outputs from the XP Swim software are in the appropriate formats to enable the local authority and the Environment Agency to update their local surface water flood maps. So that would make life a lot quicker and easier for everyone and enhance the local knowledge. Be aware of the local flood history. Again, lead local flood authority will have that to hand. And any flood defence asset information, which could, stretching out, include the Environment Agency. Both the Environment Agency and the lead local flood authorities are statutory consultees. If there is an internal drainage board, by the way, I would encourage you to approach them, and you may well find that the internal drainage board will adopt the sustainable drainage systems if they were items like swales and basins and ponds and things like that, just to be aware. I won't go through all of this, but these are the relevant questions within the LASU guidance that will be asked of you during this pre-application process. So you can see here there's a lot of data that you need to be armed with when you do enter into these early discussions, and it's really important that we build up a clear picture of not just the land survey of our new development, but what the context of that is within the watershed that the development is being placed within. Again, within the document, there's a nice guidance here showing you the level of information. On the right-hand side, the documents that need to be submitted at various stages of the planning process, from pre-app all the way through to reserve matters, etc. You can see the extent of information that needs to be required. This would be helpful to share with your clients, because obviously you're going to have to do a lot more work early on in the process, which you need to get paid for if you're a consultant, and the clients are probably only just starting to realize that this is kind of coming through. So hopefully this will help you with your discussions with the clients themselves as well. And as I mentioned, the statutory consultees will be the lead local flood authority primarily, along with the Environment Agency as well. So obviously keep in touch with those stakeholders too. So looking at this non-statutory technical standard, right at the introduction phase of the document itself, they're mentioning the layout of the development and the drainage system, and the fact that we're looking at trying to mimic the natural drainage flow paths. So we're trying to utilize this existing topography. We don't want to, post-development or during the design phase, have to do a lot of re-landscaping or enhancement of drainage networks, etc., when you can work in sympathy with the overland natural flood flow routes. Ludmilla will show you how you can really quickly and really easily use the topography and identify these, what we would refer to as blue-green corridors, and then hopefully that will be passed on to architects to better plan out the development itself in sympathy with the natural environment. And again, I feel as though we've missed this opportunity historically to date. So within the guidance, there are a number of different chapters, a big emphasis on flood risk outside of the development. How many times have we built an infill development and balancing the cut and fill? We've raised local land levels. We've raised a platform within an existing neighborhood maybe, and they were creating runoff from that platform, and it's often sort of flooding off into the back gardens of the properties of the neighbors who were probably against the development in the first place. So there's a key emphasis on looking at flood risk outside of the development, a whole chapter on that. We'll cover this with XP Swim very shortly. We're looking at the flood risk within the development, and this is something that we have been focused on. We've looked at things like no flooding for the 1 in 30-year return period. We've been testing for the 100-year, adding in for climate change. Again, you may just find that certain local authorities are asking you to ensure there is no flooding for the 100-year return period and add in for climate change as well. So again, you can engage early to find out what the targets are for your particular site. And the fact that the proposed drainage system must be designed to accommodate any existing flow that may occur from the upstream catchment. And I've known of projects that have been built at the bottom of sloping sites, for example, and the run from the slope has then created a flood going through the development. Sometimes when the development's being constructed, we've had flooding issues because that hasn't been considered historically. So what I'll do, that's basically the introduction, and what I'll do is I'll run live with the MicroDrainage program just now to provide an overview of a site that's been designed within MicroDrainage. Here's the plan view, and this is the site that I'm going to hand over to Ludmilla to then put into the context of the watershed itself. So looking at the site, we've got a stormwater and a foul water network designed within it. What we would do post-design is run a check. So we have within MicroDrainage a series of wizards. Seasonal return period wizard would do a hydraulic check on the system for a range of return periods. We have a climate change wizard as well, where you may focus on one return period, but a range of different climate change impact. We can also run a discharge wizard and a design audit wizard. For the lead local flood authorities, typically, I would say the discharge wizard would be the appropriate one. If you're submitting for an adoption through Sewers for Adoption, then the design audit wizard would be the appropriate one for the water company. You could run them both, not an issue. But if I just click on the discharge wizard option just to show what it would run, and I've got the results out already. It only takes a minute to run, but I've, to save time, already run it. We would run the summer and the winter profile events. We would check for all the different storm durations, typically from 15-minute all the way up to 7 days, 10,080 minutes, that is. We can run for a range of different return periods. In England and Wales, we would run for the 1 year, the 30-year, the 100-year. In Scotland, we'd run with the 200-year for the floodplain levels. And then I've added in 30% for climate change, but I am aware that the latest EA guidance, they actually came out in March last year, at the higher end, they're now advising on the FDGIA projects for us to take into consideration 40% for climate change. So again, you can add in the appropriate requirements based on your discussions with the flood risk manager. So what we would do is we would input the greenfield discharge rates that we have calculated relevant for this site. So for the 1 year, the 30-year, and the 100-year, these have been typed in. And then we would calculate the greenfield discharge volume. And in our case here, we can see that there is a figure of 1,268 cubic meters of runoff from this greenfield site before it's developed. And then we would run an analysis with our post-development scenario. And that's what I've done. And we have the results. So if I look at the discharge wizard results, in summary, the green is telling me that we're okay. So the discharge rate checks appear to be okay. The discharge volume check appears to be okay. And we have a red text on minimal discharge check. The minimal discharge check is applying the first 5 millimeters of rainfall onto the impervious surfaces and seeing what runoff we're getting from those impervious surfaces. So if you have zero discharge, so if everything went down to a soakaway or an infiltration basin, we would potentially have zero positive discharge. That's the only time this would occur. But in our case, we have a flow control and we are discharging something positively off-site through some form of flow control. So if we have a look at the tabs on the left-hand side, in terms of discharge rate, these were the greenfield discharge rates in the column I'm just indicating with the mouse here now. And then post-development, we're just a tad underneath those greenfield rates. So we're getting little green ticks there saying, great, we've hit the 1, the 30, the 100-year discharge rates post-development. How have we achieved that? We've achieved that along with reducing the volume. The only way we're ever going to manage this is to have the opportunity to infiltrate into the ground. So with clay soils, unfortunately, the likelihood is you're going to get a greater volumetric runoff post-development than you will pre-development, in which case we would be restricted back to the Q bar figure for every return period above the 1 year. So there would be a very, very much tighter discharge rate. However, if we have infiltration opportunities, we would take them, infiltrate into the ground, and then we can reduce the volume that we're discharging off the site. Just a quick look at the first 5 millimeters of runoff. We're generating 20.9 liters per second. So should this be a site with a risk of diffuse pollution, so if we had a lot of roads and car parking areas and you needed to know what the size of the petrol interceptor had to be, it would need to cope with, say, 21 liters per second discharge for that first flush, the first 5 millimeters of rainfall. So that's the context. If I look at the summary of the results, just a quick snapshot. Having run the analysis, we can see here that we can identify what the critical storm duration is at every location within the site. I realize there's a lot of numbers to see there. I've selected in the storm selector, it's just the return period I'm interested in, the 100-year. So this little button here will sift through and tell me what the worst case is for each location within the site for the 100-year return period. And I can unflag the pipes that are okay. I can switch off the pipes that are just surcharging, but not flooding. I can switch the pipes that are generating flood risk. And then we're just back to where the flooding's occurring and what is the sort of most common critical event. Well, in this case, for this site, it happens to be the 15-minute, 100-year event, and I've added in for climate change. So I'm going to hand this information over to Ludi, and then Ludmila's going to now take a look at the context of our new development within the catchment and run analyses to show what the impacts will be.
Thank you, Peter. I will first go back to our PowerPoint. And first question would be how much data is available. As Peter mentioned, typically we would look only within the development we have. So we will have the development, we will have the TTM or survey information for that particular site, which would only be inside these red lines. What happens outside, we wouldn't know, because typically we wouldn't be asked to check for it. However, the guidance is changing. Now it's not statutory. Perhaps in a few years it will become statutory, and everyone would need by law to check what's happening and how does this development affect the outside catchment and how does the outside catchment affect this development. If we want to look at a bigger picture, nowadays we have a lot of data available. We have available satellite images, which can be easily downloaded from GIS softwares. What I did in here, I did overlay my CAD drawing with a picture, and I can see that actually my site is sitting very nicely within the existing village or town. And definitely there will be some water interaction in between those two. As per LASSO guidance, what I'm actually interested in knowing what will happen once it rains and what will happen outside of the boundaries of my site. So what we are going to do today, first we will import our MicroDrainage model into XP-Swim, and I will take you through step by step how do we build the model, and you will see that we don't need as much information occur from the beginning. So all we will do, we will import our microdrainage model, we will add the background image, we will add the DTM, and nowadays, you know, there is a free LiDAR data available for the whole country. And what we can do, we can always combine two data sets. You can take a very detailed data set for your existing development and combine it with a bigger LiDAR. So just replace this location on the LiDAR with your information. It can be done within different softwares like road design software, GIS software, or even within XP Swim. You can just overlay one on top of another. And then we will have a bit bigger picture. We will run the model to know how does our new development affect existing area, and how does existing catchment affect our development. So to give you some heads up, our ground profile runs from north to south. So north it is high and south it is low, and our development is kind of in the middle. So just to understand how the existing development affects the existing catchment, we will only import MicroDrainage, we will create grid, and we will run the model, and we will see how it runs off. But to understand how the upper side of the catchment affects the existing developments, we will introduce something called rain on grid. As we don't know anything about existing drainage systems, assuming we don't know anything about existing drainage systems, we will run it for a worst case scenario, considering that all the drainage systems which are located in the upper land are completely surcharged, and all the ground is 100% saturated. So there is no infiltration available, there is no space for water to go inside the drainage system. So all the runoff from this upper yellow area will just naturally come through blue-green corridors, right? So it will follow the blue corridors and come wherever it comes. So let's see what will happen. So I have one model which is ready and one model which I will start from scratch. So I will start a new model and I will call it, say, test. We are working in metric, so I will select metric, and I will start with importing microdrainage file. So I just select my microdrainage file, I say open. It takes literally seconds, so my microdrainage data is in. I will add my background image. Unfortunately, I'm not a very good GIS software user, so I couldn't create it georeferenced, but I'm sure in your workplaces you have people who can do that. But I will just type in the coordinates. But if your image is georeferenced, it will automatically pick it up. Otherwise, you would just need to type them in to give a reference where it is. So the picture is in. What we had as well, we had a CAD drawing. So I would like to load my CAD drawing for reference as well, to just be able, so you can see I can tick it on and untick it, just be able to see where my future development is coming. The last thing I need is my surface data, right? So I have a file which is txt, but you can use, there are plenty of formats which we support. It can be anything. So we can see that the profile of our ground, it goes from high to low, right? And north is high, south is low. I will untick the surface. It will stay underneath. We will still have the z coordinate available. So at this point, what I would need to do is I would just need to create a grid, right? So let's create a grid. I would want my grid to be 5 meter by 5 meter. So for urbanized areas, 5 meter grid is the minimum acceptable by environmental agency. They like 2 by 2 grids, or sometimes even smaller, it depends, but 5 by 5 are acceptable as per their guidance. So after having the grid in there, what I would want to do, I would want to use the most dangerous rainfall, right? The one which is the critical one. The Peter identifies that this will be 1 in 100, 15 years winter profile. When we import microdrainage file, it imports our design criteria rainfall, so the one we used for sizing pipes. So all I will do, I will just quickly recreate the rainfall. I will click create storm. I will use FSR. I will call it critical. I will use the ratios which are for my location. So 15 minutes, winter, return period 100, right? So In here, I won't even consider the climate change, but if we want, we can then create another rainfall like that and just add a multiplier, whichever we like for climate change. So if we want 30%, 40%, etc. So what I will do now, I will just tell to the software to use only that rainfall, not the one which we had originally imported, but the new one in the simulation. Right, so this is how I would set it up. Now, just to save time, Blue Peter's fashion, yeah, we have a ready model where I already have this all set up and I have the results. So what I did, I have my grid, so I have everything, I have my surface. I would click maximum water there. And what I can see that there is some water. So if we just zoom in, we can, I don't know yet where the water is coming from, right? So I can click just water depth and I can play it. And when I play it, I will be able to see better from which locations the water is coming. So if I go a bit back, perhaps pause it, we can see that there are some manholes quite upstream of our networks which are flooding, right? So obviously maps some type of results, right? Which we love to see. But which manholes are flooded, we can easily see in MicroDrainage model, right? If we go back in here, we can easily see which pipes and manholes are flooded, right?
The question that's just come in, Lily, about can this be shown like as a profile, as a long section?
Yes, we can see the long section of the drainage system, right? So we can do that and we can play it in here and we can actually see where the flooding indicators are. Right, so there are many ways how you can export the results and see the results in XP-Swim. As well, you can have graphs, right, available where you can see graphs for your manhole and your pipes, right? Plus, you can have tables where you can manually just generate tables. But I won't go through it a lot, just so I can, I don't know, create a table and just manually just add some items. I'm not sure even if they have any results, right? The items we would add, but so there are something results doesn't exist. Perhaps we didn't run it for that, but we did show how to see the results of your simulation a lot in XP-Swim in our previous webinars. Or if you want to see, we can always have a personalized demo for any of you guys. But today I just want to show the concept, how to approach such situations when you need to assess how the development impacts outside and how the outside impacts the development. So in here, we can see that it's actually some manholes are flooding. How deep is this water? Let's check. So for every result, we can get display result values, and it will show a value for every single cell. Right, so if we zoom in, we can see in here, the water depth is really insignificant. 1 centimeter, 2 centimeters, somewhere it shows 0. It doesn't mean that it's 0. If it has a color, there is a water depth, it means it's just less than 2-point precision factor. So it's perhaps 0.09 or 0.01, right? So there is a number. What we can do, we can restrict our display range to show anything which is bigger than 2 centimeters. We'll assume 2 centimeters, first 2 centimeters are not significant. It can be any number, right? And so we can see the huge amount of water disappeared. But then if we dig back our CAD file, we will see where actually our development ends, right? And where the existing starts, right? So for instance, in here, we can see very clearly that there are some potential of flooding. And if we zoom in, we have 11 centimeters of water, 13 centimeters of water, 14, here 7. So we don't know if it will flood or not, but perhaps this is something to be very careful about and to check where this water ends up. As easy and quickly as that, we can see how the flooded water out of our development, where it moves. So the next stage would be to check how does the water which is generated in the upper side of the development will affect our development, the new one. So I will go back to the model which I'm creating from scratch, and what I will do, I will introduce a new layer which is called rainfall flow areas. So this is this kind of sky I will use the polygon tool to digitize it. I will just draw in here, as I don't know anything about the upper side of the existing village. Because if we go to MicroDrainage, remember when we look in here, right, in our plan view, we have the areas, right? We have identified areas which we digitized, or potentially we just entered a number in hectares in here, right? What is the contributing area for every single pipe, right? We don't have this information for the north side of the site. So what are we going to do? We are going to create a sky which will make every single cell wet, but it will make it wet using the same rainfall which we are using on our development. So in a way, it will be exactly the same rainfall event. So they will start at the same time, they will have the same profile, etc. It will make the land under the orange hatch wet. And as we told, we consider there is no infiltration. The drainage system is completely surcharged. So we will see where this runoff will end up. I would need to rerun the model. And typically what we can do for this, we can create another scenario, which I did. So we can call it scenario 1, for instance. And we can have this area inactive in our base scenario, and we can make it active in our scenario 1. Right? So this is what is happening in my main model. If I check the second scenario, which is called rain on grid, go to base scenario, this is inactive in here. We can see this is inactive. If we go to rain on grid scenario, this is active, right? So we have this area and it will participate in our calculations. What we want to see is maximum water depth, right? So if we click on a base scenario, this is only this much water generated. If we click on rain on grid, there is much more water generated. Right? Remember, we restricted it. So if I unrestrict, you'll see a lot of blue, right? Because every single cell underneath the orange becomes wet. So maximum water depth gives you a maximum water depth at a cell at any point of time, right? So again, I would like to restrict it back to just get rid of small numbers, and I would love to play it as well, right? So in here I would like to restrict my play, and I would like to play it, and I would like to see what happens and how the water moves and where it goes. So I can make it a bit faster so we can actually see some patterns in here. So there are some low locations, there are some high locations. If we go back to maximum water depth, we can take a cut, like a section. We can see that there is actually some in the levels. And if I zoom in this area, right, and if I click on my cut just to bring it back, you can see this is where my new buildings are, right? So if I go to base scenario, I don't have much water in here. And remember, in a base scenario, the water was coming only from our development. So we would already perhaps know that these manholes may flood in 15-minute, 100-year return period. Perhaps we will make these floor levels a bit higher to avoid any flooding. But as soon as we click on rain on grid, where all this water from the north part is coming, we can see the extent of flooding is much, much more. And if we want to see the values of it, if we zoom in, yeah, it is 11 centimeters, 16, so this is already quite serious. So 7, 6, 12, so this can potentially flood our new houses if they are done without any threshold and the door is just level to the ground. So what I would like to do now, I would want to introduce some mitigation, right?
It's just a question, maybe.
Yeah.
Asking whether we can run simulation for different scenarios, like the 5-year, 10-year, etc., and all the different storm
in
durations.
here. Yes, so we can have this global storm. I was running 15.1, right? So, but I can tick them all and click run, right? So I can add more items and create more storms and select from my selection. So this is absolutely up to you. You can run unlimited amount of storms, and you can then have results. Your results will be available for each scenario and each storm. So let's say at the moment, if I'm running 3 scenarios and I have 1 storm, I will have 3 result maps. But if I will be running all 3, which I have in here, so 3 by 3, I will have 9 maps. So in a way, quite quickly, you can generate all different possibilities, what can happen in which rainfall event.
And then we can analyze, we could use like maybe XP tables to then show the maximum water level.
Yes, definitely. Like all the numbers of 1D or 2D are available through the tables. You would be able just, to see the numbers in here, and read what they are. So in here, see, again, I have only 1 storm, but I have multiple scenarios, so I could potentially put a drop down and select a different scenario. So if we go quickly again, so this was our base scenario, little water, so it's affecting the outside. Our rain on grid scenario outside is affecting our development, right? So the last one I want to do, I want to create some mitigation. If I go back to the model which I am building, so remember we had some of the ponding in here. So I would like to introduce a natural channel. Channel can be introduced in different ways. It can be only 2D channel or it can be 1D 2D channel. So what I do, I will create a 2D channel. I will create a couple of layers and I will load from GIS. So this is my channel. If you don't have anything in, I do it through GIS because it could be easily digitized in CAD before and then export it to GIS and import it back here. And similar with houses, this is what you would find more commonly available in GIS format, right? That you will have the buildings mapped in GIS, the outlines, and you can just import them. Alternatively, if you don't want to import them or you don't have data, right? So you could just simply digitize them in here. Right, for all the buildings which are coming in, I would raise their elevation and I would adjust it by 200 millimeters and I will adjust it for all objects under this green layer. Right, in my main model, I will have every single item which is in green higher by 200 millimeters than my DTM. And this channel, I will give it a level in my main model and it will be able to collect some of the water. So if I go back and switch to my mitigation scenario, right, you can see that these objects, they come in. So all my items, they are higher. So it should be 0.2. So we played with a bit with Peter before, but it is 200 millimeters higher. And I have a collection channel to protect these properties. So let's first in here. Right, if we go to base scenario, maximum water depth, little bit of water, rain on grid, we have more water, mitigation, we have much less water. So it's been collected by this channel and routed through and discharged to this green area. But what happens is basically if we check that it could easily increase the amount of water which goes and affects these buildings, right? And these buildings, with rain on grid, this kind of just flows all through, but when we click mitigation, it follows around the building. So if I play it, you will be able to see how it actually, because the buildings, they have the height, so you can see that it will go around till the moment it reaches 20 centimeters and then it will go through, right? Then it will go on top and it will flood the building itself. Same on others locations, you will see that it will reaches, and as soon as it reaches 20, it will flow over. If you want to see the results, when we would click properties and display result value, when I zoom in, you'll be able to see that this is 27 centimeters, this is 23. This is the reason it goes over, right? If we click our grid, so you can see how our grid goes. Right, so in here where it's less than 20, it doesn't go over. But what it does after, because this is 20 centimeter higher, it will consider it as a new level to map the water. So in here it's only 6 or 8, whatever the number is. Right, and if we move in here as well, we can see this is 20, so it flows inside the building. We can identify the postcodes which would be affected. We can quite quickly without much data involved and much work to be done. It took me less than half an hour to create these 3 scenarios and the model. You may find it more time to actually go to EA website and download the LiDAR data and to combine the data together and to create a model in XP Swim. So we take our microdrainage modeling, take a bigger area, we take an aerial picture, if we want to introduce some buildings and check if they're flooding, we can quickly create channels and items, we can run different scenarios for different rainfalls, and finally we can export all this data in GIS format, and we can submit it to either potential land acquisition people. So if this is developer and they want to buy land and they ask you what will happen, even without having the drainage system, you could just use rain on grid and you can see how the water would flow through potential area. You could just quickly draw some houses with green items, where you think they will be, and you can see how things will change and what will happen. And I think at this note, I will hand you back to Peter for some conclusions.
Great, thank you, Ludi, and thank you for the questions, folks. I've tried to answer all the questions as they've been coming in, and it's much appreciated with the engagements, etc. We'll share the answers, the questions and answers after the webinar too. So that's great. Thanks, Ludi. So I hope that's helped, folks. I hope that's put things into context a little bit better for you with regard to these latest guidance documents. I mentioned the LASU guide and just sort of focused on that because not everyone's particularly aware of the LASU guidance. Be interesting if you do the survey and just let us know whether that is something that you were aware of or not, as the case may be, just to see where we're at with that knowledge. And it's also backed up by the latest SUDS manual, the Sirius E753. It's really well covered in that document too. So the key thing is really early consultation. Would really encourage you to talk to the lead local flood authorities, the Environment Agency, water companies, IDBs if they're in the area as well would be a good port of call, I would say, right at the get-go. And then we really have to move on and move forward with more detailed analysis, design and analysis at the earlier stage to encourage better surface water management. We're looking at the long term now. So what are the consequences of things flooding, whether that be from the catchment or from our development, going way beyond the design? Are we in a good state to manage that surface water? Have we taken the overland flood routes into consideration?
Peter, I have a question from Ali. He was asking if the drainage system in the new development is considered. Yes, the model which we bring from MicroDrainage is fully considered, and if there would be any capacity, it will take the water inside, right? And similarly, if it runs out of capacity, it will give the water back to 2D. So basically, anything which comes from the north, if it hits the new drainage system which was imported from MicroDrainage and there is capacity, it will absorb this water in, considering there is space. But at the north side of the site where we did not have any information, or let's say because it's almost time consuming and it involves money to go and get information from either local authorities or water companies who owns the networks, we can just assume it's a worst case scenario and it's completely flooded, which quite often happens in this country when you have 1 week of rain and everything is just surcharged.
That's right. That's a good point. Thanks, Ali. And also, and we do that typically with XP Swim. So a lot of local authorities are working with XP Swim, and they are analyzing things like typically we're getting a lot of highway drainage where the culverts are either suffering from siltation, or there's been some kind of problem, or there's more runoff being generated upstream and the culvert's undersized. So when you're modeling existing scenarios, we could put in full extents of the drainage network if that information is available, as Ludi mentioned. But in the absence of any information, you could always do the rain on grid, which is going down the sort of worst case scenario approach. And certainly in terms of engaging with people early on and doing something very quickly and easily, which is probably going to be the worst case, I think is a good way to think about it.
Another good question from Matt. Does the collection channel layer changes or overrides the surface data? Yes, it does, and you can choose which level it will run at. So you don't need to do manipulations or wait for your road designer or draftsman to do manipulations with surface. You can easily create layers which will override the surface, and these new overwritten levels would be considered for flood modeling.
Yeah, that's a good point. So we can bring in, yes, to enhance that DTM. Say you're working with XP Site 3D, our road design package, we could export out just for the roads and the new road network, the revised levels, and then bring that into the DTM, and it would refresh in that area there. We could also, within XP Swim, not only could we create those kind of channels within the DTM as objects, as depressions within the DTM, without everything being retriangulated, but we could also build up as well. And those items, we could have them rising up as water levels rise. And what I'm thinking now is if you had a flood barrier, so maybe you have a flood barrier underground, and when the water level in a river or within a manhole reaches a certain level, then the flood barrier starts to rise up above the ground. We could even model that as a dynamic elevation shape. So yeah, maybe we can cover that in future webinars for you if that's of interest.
I have another good one. Amir, he is asking how we decide what would be the extent of rainfall. For example, rain would be falling on how much area. I just decided on how much information I had, how much DTM I had available, but you can make it as big or as small as you think is required.
Yeah, what I'd probably do there is go for the watershed extent. So we need to sort of step right back and then identify where that ridge line is, where the watershed is, and then I'd probably apply the grid around the watershed, and then you can deluge the whole watershed.
Yeah.
One approach.
Robert is asking about the upper area, if it had been impermeable or greenfield. It's been mixed, so we can create land uses and we can give them certain numbers if there is any infiltration or not. For my land use, I completely ignored the infiltration, so all the runoff which was falling on it was running off, right? But in real life, you can add some infiltration if you want.
Yeah, and if it was a mixed use, so maybe it was farmland or something like that, we could incorporate like initial losses.
Correct. And continuous losses, yes.
Exactly, continuous losses.
We can incorporate ground saturation as well.
Yeah.
Soil saturation.
And in terms of the hydrological methods that you can use, there are many hydrological methods that we could incorporate. The latest one, if we're looking at that kind of scenario, would be like RefH2, where the ground, if it was to be like farmland, then the ground becomes increasingly saturated throughout the event. That's taken into consideration as well. So we run FSR, FEH, RefH2, as well as a lot of different hydrological methods that are used in the US and in
Middle East,
Australia and the Middle East, etc. Yeah, great. Thanks for the questions, folks. It's really, it makes it really interesting for us. We love putting these things together and sharing this kind of knowledge. And it's when you get the interaction, it really comes alive for us. Otherwise, we're just kind of talking to a microphone and a screen here. So it's really much valued. So yeah, so hopefully you can see how MicroDrainage and XP Swim combined can provide the industry standard technology to help you with compliance at a really early stage. And don't be fearful, I'd say. Rule number one, don't panic. If you're being asked for a lot more information, that's fine. And as Ludi mentioned, we can access information there, LiDAR data, etc., quite readily. And we can manipulate and use that to good effect in fairly short order. So don't worry about that. If you need any extra help, we will be running more webinars. The plan is that we run 2 streams of webinar. There'll be one stream concentrating on sort of drainage design, so MicroDrainage, and then another stream on the modeling aspects, which is becoming increasingly requested, and that's the XP Swim side of things. So we'll be running in parallel, probably around about every 2 or 3 weeks we'll be running webinars now, so there'll be an increased frequency to cover all of this. If you need help using the softwares, we run regular training courses. So just looking up ahead, between the 7th and the 9th of February, we have training here at the Newbury Training Centre. Training courses A, B, and C. A and B are the most popular ones, design fundamentals, designing flow conveyance systems, course B being modeling and simulating, so testing and putting in storage structures to mitigate against flooding at the design stage. Course C, we're using the graphical interface. We're using CAD data and auto designing and a little bit more advanced modeling with infiltration systems as well as attenuation structures in a graphical format is course C. So just go online to the XP Solutions website and you can book places online there. I think there are spaces available.
Sorry, Peter. Very good question. Which LiDAR would be best suited for this, DTM or DSM? On one hand, many may think the digital surface model, which is DSM, is good for such purposes because you don't need to digitize the houses, right? But if you are using a DSM, be careful because if your property is obviously identified on your LiDAR, there is no chance you can make water flow inside it, right? So because it will be much higher, so you completely eliminate the possibility of software to put the water inside the house, right? So I would use DTM and I would digitize all the infrastructure pieces separately within the software rather than using DSM.
Good point. Yeah, I agree. I would go DTM myself. It's kind of like a bare earth model. And then from that, again, with XP Swim, importing GIS data is really easy. And we can import the attributes of that data. So we could bring in, for example, all the buildings, and then we could set heights of all the buildings to say 150 millimeter to replicate a threshold or whatever the depth or the height of the threshold would be. And then we can see if the water goes above that 150 millimeters, those buildings that are more at risk to flooding. And those polygons of flood extents can then be brought back out into GIS as well. So we could identify the postcodes of the properties at risk, for example. So yeah, really good questions. Thanks for that. And it leads on to the next point here. In terms of training with XP Swim, we're running the next series of 3 days of training between the 14th and the 16th. I don't know if we're going to have like flowers and chocolates available on the 14th, but you may have to bring your own for that one. But there's 3 days of XP Swim training, which we love, and I hope you do too. The next webinar will be taking place on Wednesday. We're back to our Wednesday sessions for the 23rd of February. It's going to be on microdrainage, and we're just going back to basics. So it'll be like Drainage Design 101. So back to basics with drainage design to help people that have requested that kind of fundamental training, if you like, in a lunchtime webinar. And the first time ever, we are going to run an XP Site 3D training course. It's a one-day course, which is our road design package, XP Site 3D, incredibly popular. So many people using XP Site 3D now. It's very intuitive, very easy to use. Everyone's getting on great with it, but we are writing a day course so that we can give people like tips and tricks on how to utilize the most of XP Site 3D, and that's run for the first time ever on the 1st of March. So thanks for those that made the request for us to run a course, and we look forward to seeing you then. If you watched it as a group, if one of the group could email us all the attendees. And ideally, in future, if you could each individually register, even if you attend as a group under one, but if you were to each go in and register, then you will each receive that email link to enable you to each download your CPD certificate. Just makes life a lot quicker and easier for everybody. And on that note, I'm just looking over at the questions. Ludmila's still typing away and responding to some of the questions. Really appreciate your feedback and interaction during this presentation on assessing flooding consequences of a new drainage design. So from me, it's goodbye, and through Ludmila.
Yes, goodbye.
And see you again in the future webinar.
Yeah, see you in a future webinar.
Take care. Bye for now.
Bye-bye.